Okay, this is 6.8b of geometry. So we're going to work on planning a coordinate proof. So that's a proof where the shape, we're working in the coordinate plane. So we're working on a graph. And so you can see here, they're trying to prove the trapezoid mid-segment theorem. So they drew their trapezoid. And why do you think they used 2's in their point coordinates? Well, what do we know about these points? These points here are going to be midpoints. So if we have 2's, when you divide 2 by 2, you get 1, right? It's going to be a lot easier than if we just used a plane B and a plane C instead of 2B and 2C, because otherwise we'd be working with decimals. So, draw and label your shape, and then write out what we're given and what we're trying to prove. So, we're given a trapezoid, ORAP, where MN is the midsegment, and we're trying to prove the mid-segment theorem. So we're trying to prove that the mid-segment is parallel to the two bases, and we're trying to prove that the mid-segment is half of the sum of the two bases. So if you take the top base and add it with the bottom base, and then you take half of that, that'll give us our mid-segment. So we would find our midpoints and then use our slopes to figure out that those lines are parallel, and we use our distance formula. We're going to try our own doing the triangle mid-segment theorem, and we're going to plan it out and execute it. So first thing I need to do is I need to draw a triangle. Okay, that's my attempt at a triangle. Well, we'll make it so that it actually goes on the axes. I'm struggling here. Okay. So here's my triangle. So I'm going to label my points. So this is 0, 0. Right, and then I'm just going to choose some letter. Let's say this bottom, my base there on the bottom is 2a long. So then this is a coordinate 2a, comma 0. And let's say my x up here is 2b, and my y is 2c. Doesn't matter what you're labeling, you're choosing. So then I'm going to draw in my mid-segment. Let's say the midpoint's about there, and it's about there maybe. So there's my mid-segment. It's a little rough. I need to figure out what those coordinates are. So I can use my midpoint formula, which, if you don't remember, is x1 plus x2 over 2, comma, y1 plus y2 over 2. So we'll use that with the points 0, 0 and 2b, 2c. So I get 0 plus 2b over 2, comma, 0 plus 2c over 2, which turns out to be 2b over 2, comma, 2c over 2, which is just b, comma, c. So midpoint on the left is b, comma, c. And then I'll use a midpoint formula with my other 2 points. So let's change the colors, how about? So now we're going to use the points 2b, 2c, and 2a, 0. So we get 2b plus 2a over 2, comma, 2c plus 0 over 2. So this is going to turn out to be, we'll leave it as 2b plus 2a right now, over 2, and we get 2c over 2. So the 2c over 2 is obviously going to be just c. You can, on the left, to figure out what our x coordinate is, you can divide 2b by 2, which will give you b, plus, and divide 2a by 2, which will give you a. So this is the point b plus a, comma, c. Okay. So now I need to check, look at our theorem up here. It says that the base and the mid-segment are parallel, and that the mid-segment is half of the base. So let's start with the parallel stuff first. So let's work with slopes. So remember, your slope formula is m equals y2 minus y1 over x2 minus x1. So we can use this to figure it out, but also let's just look at this for a second and why we maybe wouldn't even need to. My y here is 0, my y here is 0. So this is a horizontal line then. So we know the slopes of horizontal lines are 0. The y here is c and the y here is c. So this is also a horizontal line. So the slope of this one is going to be 0. If you weren't sure of that, I'll show you how you could use your the slope formula. So let's try the mid-segment one. So we've got the point BC and B plus A, comma C. So this is x1, y1, x2, y2. So M equals C minus C over B plus A minus B. C minus C is just 0. B plus A minus B is just going to be an A. 0 over anything is just 0. Right? So if you have proof that they are horizontal lines, the y's are the same, you can just say the slope is 0, or you can use your slope formula. So they have the same slope, so they are parallel. And then we're going to figure out the distance. So remember our distance formula. Stick it over here. x2 minus x1 squared plus y2 minus y1 squared, and that's all under our square root there. Okay, so here's another option, right? I can use my distance formula for both of them, but look at my bottom base, right? If I'm going to the right, if I have an x-coordinate of 0 and then I have an x-coordinate of 2a, that means I just went over 2a, right? And in this case, since we know they're horizontal, right, that's only because we know they're horizontal, because the y doesn't change. We can do the same thing with our mid-segment, but let's just use our distance formulas anyway and figure it out. So if I use the points 0, 0, and 2a, 0, I'll do this one, x1, y1, x2, y2. So I get 2a minus 0 squared plus 0 minus 0 squared. So this is the square root of 2a with the parentheses still around it, squared plus 0 squared. If we have more than one thing, so we have 2a, we have 5b, we have x plus 2, right? If anything in there is more than one number or more than one letter, then you need to keep your parentheses around it. In the case of 0 minus 0 equals 0, right? So now we just have 0 squared. We don't need parentheses around it. Also, if it's a negative 2 squared, you need parentheses to keep the parentheses around your negative 2, right? So this is just a square root of 2a squared. Two different ways you can solve this. So the square root and the square, or the second power, cancel each other out. They're opposites. Just like when you add and subtract, they equal 0, right? They get rid of each other. In this case, these are inverses. They're going to undo what the other one does. So these are going to cancel out, and we'll just be left with 2a. Okay, see how we're just left with 2a? The other way you can do it, if you're going to bring in that 2, that exponent, that squared, you got to bring it into both things. So 2 squared is 4, a squared is just a squared, and then you got to take the square roots of both things. You can split this up if it helps to be the square root of 4 and the square root of a squared. But then this turns into 2 and a. So your answer is 2a. So our bottom guy is 2a long. Then we're going to do the distance formula again, this time for our mid-segment. So with points BC and B plus A, comma C. So this is x1, y1, x2, y2. So square root of b plus a minus b squared plus c minus c squared. So that's a square root of b plus a minus b is just going to be an a squared. Plus, and c minus c is 0, so this is 0 squared. So this is just the square root of a squared, which is just a. So we get, in fact, that the mid-segment is half of the base, right? Just like our theorem said we would. And there's your homework.